Welcome to Monochemistry. Today we're going to look at the differences in properties between ionic and covalent or molecular compounds. But the key here is we're introducing the idea that the structure of the chemical compounds, how they're put together, actually shapes or determines their properties. Okay, so what I have here for you is actually a screenshot of page 160 of your textbook, and you can find that table on page 160 of your textbook. It talks about some of the different properties, like for instance the state of matter at room temperature, the melting point, the conductivity, the solubility in water, and the conductivity when dissolved in water. And as you can see, there's some pretty noticeable differences between the ionic compounds and the molecular compounds. And here's basically what I want you to do is I want you to jot this down. I want you to jot this table down, have it in your notes. It's very important. And over the course of this unit that we're going to do, Unit 2 of Chemistry 11, we're going to, first of all, discuss what the differences between the bonds are that make up these compounds, but also we're going to determine how the structure of these chemicals actually determines what their properties are. So in other words, at the end of this unit, you'll be able to answer the question, why? Why is a covalent compound a gas or a liquid or a solid at room temperature versus ionic compounds, which are always solids at room temperature? Why do ionic compounds have a high melting point versus covalent compounds, which have a relatively low melting point? So we're going to look at that. Before we do that, though, I want to just quickly go over some of the basic ideas between ionic and covalent bonding, which you may or may not have talked about in the past. So make sure you write some of this information down, please. First of all, as you know from our discussions in class this year and hopefully from grade 9 and 10, ionic compounds involve metal parts and non-metal parts. Sometimes there's polyatomic ions involved, but generally speaking, like sodium chloride, you have a metal part and a non-metal part. The metal part takes on a positive charge and the non-metal part takes on a negative charge. And it's those charges that allow us to determine that it's an ionic substance. Okay? But how do we get to that point? What happens in order to get those things, the positive and the negative charges? Well, first of all, ionic bonds involve a transfer of electrons. Why do these substances, like sodium and chlorine, why do they change the number of electrons that they have? Well, the simple answer, and it's not really that simple, but the simple answer is because sodium and chlorine would much rather have a different number of electrons than they do. And that's because they're more energetically stable when they have those different numbers of electrons. So let me show this. So sodium has 11 protons and 11 electrons, as you can see here. And what happens to it over the course of this process is that it loses one of its electrons. And now it has a +1 charge. So 10 electrons, 11 protons. Now why? Why would it do that? Well, I want you to look on your periodic tables. Notice that sodium is in group 1. It has 11 electrons. When it loses that electron, it now has the electron configuration, or the same number of electrons, as the nearest noble gas. And if you don't remember anything about anything in chemistry, you know that the noble gases don't react. That's why they're the noble gases. They don't react with things. So they're obviously very stable. So the sodium wants to be more like the nearest noble gas, and that just happens to be neon. Chlorine has 17 electrons and 17 protons. Chlorine's in group 17. Notice it gains an electron. It gains an electron to look like its nearest noble gas, which is also very unreactive. So when they do this, when sodium transfers its electron to chlorine, both of these atoms become much more stable and much happier. Okay? So that's the gist of it. Now, when they do that, it just so happens that when sodium gives an electron to chlorine and chlorine accepts that electron from sodium, they like each other now. They like to hang out because This one has a positive charge, and this one has a negative charge. Positives and negatives attract each other. I give you something, we're stuck. We're sticking together. And if you have several sodium and chloride ions doing the same thing, then what you form here is known as a lattice structure. Notice that a positive ion is surrounded on all sides by negative ions, and a negative ion is surrounded on all sides by positive ions. And that is a lattice structure. Would be a good idea to jot some of this information, including what a lattice structure is, down in your notes. Let's talk about covalent substances now. How is this different from what we just looked at? Covalent bonds, instead of involving a transfer of electrons like we saw in ionic bonds, actually involve a sharing of electrons. Okay, so just take this example here. We've got two hydrogen atoms, and these hydrogen atoms, again, are not energetically stable. They would much prefer to look like the nearest noble gas. But instead of transferring electrons and sticking together in the same way that the ionic substances do, what they decide to do is they decide to share. And when two hydrogen atoms share their electrons, they now have the noble gas configuration of helium, which has two. Okay, so covalent bonds involve a sharing of electrons, and typically it's non-metal substances, two non-metal substances that will be involved in a covalent bond, whereas in an ionic bond it's a metal and a non-metal. Okay, and again, overall, why do these things form covalent and ionic bonds? It's so that they can become more energetically stable, happier, more like the nearest noble gas. And that, in a nutshell, is the intro to chemical bonding. We're going to be able to answer by the end of this unit how this determines the properties of a particular substance or various substances.